for 3.5, pooling it together. And when you read this, you will see that what's happening here is that we're adding together a of x plus d of x. And so that's going to make a new function called g of x, which is going to tell us how fast the water is draining in both pools put together. So in number 1, you're going to talk about that this is telling us how fast the water is draining, or the water level, really, in both pools put together. And now to create the new graph, we have to figure out at least 2 points to make a new graph. So the way I'm going to figure out the 2 points is I'm going to say, okay, well here at time 0, we're going to have the total amount of water is going to be the amount in Dane's pool plus the amount in Allie's pool, which we know from the previous one. And then the one other point I know is that at 10 minutes, each pool is going to have 14,000 gallons in it. Right, 4, 8, 12, 16. Yeah, it was 14,000 gallons in it. So let's make a chart to make that clear. Okay, so this is 3.5. And we're going to add a of x plus d of x. And we're going to end up with this new function, which they told us to call g of x. So I'm going to make a table here. So x is our minutes. That's the independent variable. And we know when x is 0, we know the value for a of x was, at the beginning, Allie had 28,000. Okay, and we know that Dane, that's the value for d of x, so d of 0, Dane had 24,000. So at the beginning, at time 0, the total amount of water in the pool was 52,000. All right. And then the other time we know for sure is at 10 minutes, both Allie and Dane each had a water level of 14,000. Because remember, she was going down by 1,400 gallons a minute, and he was decreasing by 1,000 gallons a minute, so that turned out to meet at 10 minutes 14,000. So if we add those, we get 28,000. So we can do what we did before and figure out our slope, and we know our intercept. So our y-intercept is 52,000. Our y-intercept is 52,000, 52,000 gallons. That's what we started with. So B equals 52,000 in y equals mx plus b. But we have to find m. So slope is just rise over run, or the change in y, that's going up and down, that's the rise, over the change in x. So the change in y with respect to the change in x, and we could just get that by subtracting. So g of x is the same thing as y. We just refer to it as y because it's the y-axis, and this is function notation. So 52,000 minus 28,000, 12 minus 8 is 4. 4 minus is 24,000. Oh yeah, and we knew that. So, and the change in x is 0 minus 10 is negative 10. So for every 10 minutes, together the pools are going to lose 24,000. Actually, are going to be down after 10 minutes. It's going to be down to 24,000. So, no, I'm sorry, it is going to reduce by 24,000. So if you divide that out, you end up with Sorry, was that clear? So my y decreased by 24,000 and my x decreased by 10. Actually, sorry, went up by 10. And so we have negative 2,400. Okay, so now we can write y equals mx plus b. Or we'll write g of x. G of x is synonymous to y. It's the function notation way. Slope times the variable. Our slope is negative 2,400. And we started with 52,000. Oh, that was a different question. That wasn't part of question 2, but I did all of that. I have not yet made the graph, though. So let me see what question that was for. Write the equation for the function g of x. Okay, so we just did number 3. And number 4 says, should the algebraic equation of g of x be the same as the algebraic function created from the graph? Why or why not? All right, I'm going to put that on a second video, I think.